Hello. Happy Saturday, data science streamers. All of you who are out there, welcome. Welcome to the stream. Trying some new things today. Well, I'm always trying new things streaming because every stream is brand new. Anyway, my name is Carl and I'm a data scientist in the Bay Area of San Francisco, California. I actually live in a town called Albany, which is near North Berkeley. Now I'm like fixing my hat, looking at myself in the video. I should have done that before I started. But anyway, very happy to be here. Today I have a special all-new stream that I've never done before. You also might hear some differences in the sound if you've seen my streams before. Hopefully you're noticing that the music quality sounds better. I don't know. Let me hear on the chat if you think the music is too loud or too soft, if you can't hear me or can't hear the music. But anyway, I will get right into it. If you've seen my streams before, you know that I talk for a bit at the beginning, but eventually we're going to get into some live coding and live data science analysis. Hey, Maddie! Thank you for joining. And I'm following your advice, and we are now listening to Pretzel Rocks. This is one of the copyright-free channels from Pretzel Rocks, which my good friend Maddie Two Shoes recommended to me. I was getting advice from other streamers on where they get their music from. I was a little bit bored with the Spotify channels I was using. The other new innovation this week is I used a ducking compression filter to get the music volume just right. We'll see how it works. Anyway, let me go into explaining. As I said, I always spend some time explaining what I'm talking about at the start of each stream, so that for each stream, if you don't know anything about this, you can get start. Oh, looks like Pretzel Rocks is even talking into my chat. Now playing Stop by Approaching Nirvana. We'll see how this goes. Anyway, getting on to the content, what is churn? For everyone who doesn't know already, churn is subscribers, customers, or users quitting, unsubscribing, or unfollowing, or canceling, or leaving. Maddie says, in the free version, it writes in chat. So we're using the free version. I actually like seeing the now playing. I like to know what I'm listening to. You know, might want to look these guys up later. You never know. Anyway, churn comes from a term called the churn rate, which is the percent of customers that drop out. But nowadays, churn is also a verb, and you can say something like, the customer churned. Or even, I'm churning from Spotify because I'm sick of all their copyright-free music channels. Actually, I'm not going to churn from Spotify because of Pretzel Rocks, just saying. Churn is also a noun, and you can say, make a churn report for last quarter, or even, that customer is a churn because they canceled their contract. So that's all the churn speak in the business. What is fighting churn with data? You saw that on the home slide. That is the book I wrote based on my experience as a data scientist at a company called Zuora. Zuora is a platform that lots of subscription companies use to run their businesses. So by being chief data scientist at Zuora, I worked on churn for a lot of different companies in a few years' time. And that's what motivated me to write the book. Unfortunately, the book is not that cheap. I'm going to be honest with you. The publisher set the price pretty high, but, whoops, discount code. Oh, my camera's not reversed, and now I got to get used to being the other way. But anyway, you can get a discount code here if you want to get the book for less from my publisher. Also, you don't need the book. Just listen to my streams, get the code from GitHub. I'll show you where in just a minute, and you don't really need the book. I mean, depends on how you like to study. If you like to learn from a book, get the book. If you like to learn from a video, hang out here with me and chat. All right, why learn about churn? It is the most common data science problem in the world. Now, I don't have data to back that up, but that is my belief, that churn is the most common data science problem in the world because every company today has a churn problem. We all want our customers to keep coming back. It's all about recurring revenue now. Also, churn is a great way to learn your data science foundations, because on my stream and in my book, we go from raw data all the way to the final result. So that's why there's a good way to learn things. It's a pretty good song, Approaching Nirvana. I don't know if I'm approaching Nirvana, but I'm not complaining. Let's see. Now, I said you go all the way from raw data to actionable results with this type of work, but what are the actionable results? The results are actually reducing churn. And if you want to reduce churn, there's a few different ways you can really do it. The first one, and the best way to reduce churn, is to have a great product. Because if customers love your product, they should keep coming back without a lot of gimmicks and stuff. Also, you can do targeted marketing. But you want to use your data to make it really useful to the customers, so it's not just spam in the inbox. You can also help your customers succeed by targeting them for training or onboarding or help when they need it, and that's a field called customer success. And lastly, you can adjust your sales and pricing to make a plan structure so customers feel like they get a good deal, but without you giving discounts. A lot of people think fighting churn is about giving discounts, because some companies do that, but really giving discounts undermines your pricing structure, so it's not a good way to go. So I think that's the background, kind of level setting, what we're talking about here. So where's the data? Actually, I don't teach churn from a real data set. We use a simulation. Let's take a look. I always start out with the stream at this point, kind of hitting some SQL queries to look at the data in a database. So I have a schema, SocialNet 7. That's the one that's going to come with a book. And I mentioned that churn is a lot about subscriptions, although it doesn't have to be subscriptions. So there's a subscription table. Let's see. Is there a subscription table? Yes. So subscriptions are all for each customer. Each one is for a customer, I should say. And they have a start date and end date and a price, although we're not too concerned with the price in this. And we've also got events. So this shows you there's an event table, but you can't really see what's in the events because they're just shown here with a type ID. So I'm going to join with a type table to show you what the events are, and I guess this is a basic SQL demonstration. I don't know. I don't know if this is interesting to people. It's so basic, but you never know. So we have star from event, and I want to inner join whoops. I want event type ID. All right, let's try that. Okay, now we can see a little bit more information. We can see that these events have a type called post. Might be a little bit more interesting if we look at one account sequence of events. There we go. So the events in this simulation are for a social network. That's why I called it SocialNet 7. And you can see that they're like, message, like, this guy likes a lot. Account number, what account is this? Account ID 2. So every event is for one account at one time, and they show what the customer has been doing on the service. Now, taken together, all these events give you a picture of what all the customers are doing. Oh, Maddie, you started learning R. I love R, actually. And I consider myself a bilingual data scientist. I did, in fact, all of my churn work, I had originally did it in R at Zora, and then I rewrote it in Python for the book. Kind of it's a better cleaned up version, but also more accessible because more people use Python. But I love R. Unfortunately, at my new job, we don't use R, only Python. So, not that that's so bad, but it just means my R is going to start to get rusty, I'm afraid. Anyway, I am definitely, the power of R is very great, I would say, especially for data munging. But so, that was an example of the data from the churn simulation. We have these events, and if you saw my previous streams, we have turned these events into a data set, which I'll show you in a minute. But here's my little information reminder. If you want to know where to get all this code, you get it from my GitHub site, which is also Carl24K, and the repo is fight-churn. So you clone the repo, you install Postgres and Python, and you have to run a simulation, which takes about 15 minutes to generate the data, at least on my laptop. Then you'll get all that data. What are we listening to now? I Promise, Amy Thornton. Okay, pretty good. Pretty happy music. Need happy music for streaming usually. So this is a summary of the data set that we've had so far. And if you've watched my previous streams, you've seen this data set a lot. You're probably sick of it, but anyway, here it is again. We're going to do something new today, though. I promise, in like 5 minutes. So there's a churn rate in the data set, shown on the first row, about 5%. And then we have a lot of metrics, also called features in the data science and statistics lingo, that summarize the data for each customer. Actually, let me show you the data set. For those of you who have not seen a data set before, this is what our data set looks like opened in Excel, which is actually a pretty convenient way to see or view smaller data sets. If it's less than like 100,000 rows or something, Excel is a pretty good data viewer. Anyway, each row we have identifying information for the account and the date the observation was made and whether or not the customer churned. And then the metrics are things like likes per month, new friends per month, posts per month, etc. So each row of the data set is a summary of each account at the time the observation was made. And that's going to be true for, well, just about any kind of data set. Yeah, Maddie, what I really like about R, speaking of like why R is cool, is the syntax for selecting is so much more intuitive than Python pandas, I have to say. You can write really complex indexing and selecting statements on R because you can intermix names, numbers, and boolean expressions in the brackets when you're selecting data in your data frame. And it's so much easier than the convoluted syntax of selecting and indexing of Python pandas. So makes R very good for data munging. Here's my 2 cents, or 4 cents on R. Now that you got me started, I'll keep talking about R throughout the stream. But we're only looking at Python today, so don't get me wrong. Yeah, I should do a stream on crazy indexing and selecting in R. It's really powerful. Anyway, so this is the data set that we have. And we looked at understanding behavior in the data sets and how it relates to churn. I'm almost done with the review before we get into new material, just so you all know. This is for everyone who hasn't seen this. You can analyze churn in this data by grouping the customers into what I call cohorts, which just means that we group them together based on their behavior on one of these metrics. So shown in this plot, we've grouped customers together by the number of posts per month that they make, which is one of those metrics. And then in each cohort, we look at the churn rate. Oh, I should have mentioned the cohorts are organized by the score. So the bottom cohort has all the bottom values on the metric, which are close to 0 right here. The top cohort has all the customers with the highest value on the metric. The average is 175. And then in each cohort, we look at the churn rate, and you can see the more posts per month a customer makes, it's very strongly related to churn, which is what the point was. And this was listing 5.1 in the book. Let's see. This is another example where we looked at ad views per month. And this is a case where you were like, or most people would be like, wow, the more ads they watch, the less they churn. Isn't that kind of weird? I guess people like ads. No. It's a question of correlation versus causation. Watching a lot of ads is correlated with using the service. So you will often see that things which you might think are annoying to users, the users who do them a lot are actually your best customers because they're doing them a lot. But you can do deeper analysis looking at a ratio like this one, ad views per post. And when you do it this way, you actually see that the more ad views in relationship to posts actually shows that viewing ads is really bad. This was all done with listing 5.1 in the book. I think maybe we should go look at it because I haven't done any code for a while, but I don't know. Anyone who's watched my stream before has seen listing 5.1. Let's do listing 5.1 later. I'm just going to keep talking about new stuff and we'll get to code in just a minute. And we'll do listing 5.1. Today, we're going to talk about something different. Everything we were talking about before was behavior. What do customers do? And demographics, also firmographics, which is the same thing for companies, means they are facts about your customers, information. So a demographic is like a fact about a person, and a firmographic is a fact about a company. And when I say facts, I mean that it's basically unchanging, more or less. We'll make examples in just a minute. But behavioral measurements change constantly, or they have the potential to change constantly. And demographics, firmographics, not so much. Although they can change. Let's look at examples. Here's examples of demographic and firmographic data you might have about your customers. All right, let's see. Demographic information might be the date of birth of the customer. And the firmographic information for a company, which is similar, might be the founding date of the company. A demographic information about a customer could also be something like a sales channel, which in this context, the channel means how the customer found you. Or, for example, Mac apps, the iOS App Store versus the Android App Store are different channels that a customer could find you through. And that's like a demographic data about your customer, even though might not be what you think of as demographics, like age, gender, where you live. But the channel your customer interacts with you on is also a useful demographic, and it fits into this analytic framework, even if it's not a personal characteristic. So other demographics and firmographics could be the occupation of an individual or the industry or vertical for a company. You could also have information about the hardware, OS, tech stack. So you might see a trend here that a lot of these demographics and firmographics are strings. So they're non-numeric data. And there's also a date that can be mixed in there. The next example shows you could have a numeric or number data for a demographic, number of household members in a family, or the company stage for number of employees for a company. That's the number. And there's more examples here. You can also have boolean demographics too, meaning true or false. An example there is an individual married, or is a company in the Fortune 500? So, those are examples of demographics and firmographics that you might have. And in the stream today, we're going to be talking about demographics. Because remember, my sample data set and simulation is for a social network with individuals. So I'm going to do all this analysis today and examples of code using demographic examples, because my example is a consumer product. But if you have a business product and you're using firmographics, all the same techniques apply. So if I say demographic and you've got a B2B, business-to-business product, just think firmographic, because it's basically the same. Now, we have to extend our data model a little bit, because remember, I showed you subscriptions and I showed you events as the core of the data model. But to store demographics, we should have another table, which is the account table. Many people would say the account table is the most fundamental table that we should have started with, but I'm actually adding it at the end when we're looking at demographics and firmographics. So the account table is going to have an ID, and let's say, hypothetically, for our social network, we have 3 demographic data fields. The channel, the date of birth of the customer, and the country. And by channel, we mean sales channel. Now this links to subscriptions by the account ID, because remember, we had account ID in subscriptions, and it also links to events too, but now I'm not showing you that. All right, let's get back to some real data, and let's look at the account table. All right, now listening to Superhuman by Black Gummy, Colleen D'Agostino. Feeling pretty superhuman with this. I think I could code for a while listening to this music. So let's look at the account table. Well, let's not select star. So we have 1 row per customer given by an ID. We have a channel, which appears to be App Store, Web, date of birth, and country. All right, let's do a little bit more SQL. I got a new, quieter keyboard also. I think my old keyboard was too noisy for streaming. But I'm getting used to the position of the keys. Right. And I'm not paying attention to my sequels. Maddie, you must be appalled at these noob SQL errors. Maddie streams SQL. All right, let's try that. Comment must appear in the group by clause. So start channel count star from account. Now what am I doing wrong? There we go. Finally got it right. So now we see that in this data set we have 3 different channels: Web, App Store 2, and App Store 1. So we assume that that's the way the customers get to the social network. Looks like most customers use App Store 2. All right, let's also look at the country. Reusing my SQL. All right, let's see. Sorting by the count, the US is the most common country. Next most common, CN, which is supposed to be China, I think. You know, I don't really like the way the Pretzel Rocks kind of like takes over my chat. That's how they get you. I might have to pay to upgrade if I'm going to keep using it. So we've got country, we've got channel, and what can we say about the date of birth? Let's say, did say date of birth, right? Was that the name of the column? Yeah, okay. I'll just see the minimum and maximum date of birth. So we have people in this data set born as early as 1938 and as recently as 2008. So that's just to show you what's in the demographic data in the account table. The next thing we have to do is get this data out into our data set. Because remember, we have this data set already. This was our old data set. It was actually called data set 2, if you read the fine print. It has all these other fields, but it has no demographic data. So next thing we're going to do is look at how to combine the demographic data with the data set. And if you didn't see how I do the data set in an earlier stream, now's your chance, because I will go over it as if we have never done it before. This is the dataset 3 sequel from Fighting Churn with Data. Listing 10.1 means that it's chapter 10, listing 1. Now we're really getting to some code. So here's the sequel. I should mention, if you have the code from the book, in the repo directory, there's a top level, and then there's the listings folder, which has a folder for every chapter. So that's how I got to listing 10.1. Now this is a SQL listing. And let's see. It's using a common table expression here first. I'll explain this part, just to set a few parameters. Even in a SQL, I like to have a clean separation between the variable parameters and the hard-coded logic. So this is where I set a few parameters. Let's ignore that and look at the body of the select. So I'm going to select account ID, observation date, whether the customer churned, and also the channel that we were just looking at, and the country. Now for the date of birth, I'm going to do this little bit of logic here. I'll explain that in a minute. Let's go look at the join first. This is all we're going to join with the account table on the account ID, and the account ID and those demographic fields have to go in the group by. So this is all a group by, like I was saying. And we're going to select channel, country, this expression using the date of birth, and then we're going to select all the metrics. And this is actually the SQL select that I explained in previous streams for how you can select metrics from a table into a data set. This is actually called the pivoting of the data or flattening of the data. So on each row, we make a select statement for one metric, which has a case statement using the ID for the metric that returns the value for that ID, otherwise 0. And you wrap this in a sum statement, and what this does is it picks out the value for one metric and puts it into one column of your data frame for your result data set. And that's because in the metric table, all the metrics are in one column, but in your data frame, you have to put them in separate columns. And that's why they call it flattening the data or pivoting the data to create a data set. And this is a great SQL trick here. So we're joining on the metric table to pick up all of those metrics. And there was already an observation table. I didn't go into that one, but that table was already set up back in chapter 4, and that's the table that tells us who churns or not. Let's run the SQL. I already have a configuration set up to run it, which means I'm going to run this program, run churn listing, which comes with a repo, and give it the arguments chapter 10 listing 1. Let's try running it if there's no typos in there. It should print out that SQL that we were just looking at. Seems to have already run it. And it's saying it saved a result here. SocialNet 7 dataset 3. Let's go to my local directory and check. Yep, here it is. Here's the new dataset. Right next to dataset 2. We have a dataset with the channel in one column, the country in another column. And now what's this in this other column? It is the customer age. And if you were wondering, you may remember that back in the database, we only have the date of birth of the customer. So how come here I have the customer age? Now, before I got screwed up trying to figure out why the code wasn't working, we were looking at this listing, and we saw that when I selected the date of birth, I actually put it in this complicated expression. Hey, Danny Spark. Welcome back. Well, the stream is going okay. If you just joined, you just missed me totally choking for like 10 minutes. I couldn't get my own code to run. But eventually I ran it on a different schema that was appropriately set up. Big screw up, but nice to have you back. Today we're doing demographics. So I was just going to explain how when I select the customer date of birth, I actually put it in this expression where I subtract the date of birth from the observation date for the data. Now that gives me the number of days between the date of birth and the observation date. And that's because I did, I subtracted them and then wrapped it in the date part expression. So this is the number of days. Then I cast it to a float and divide by 365. And that's what gives me the customer age. So this is a trick when you're extracting a demographic variable, which is a date. You can convert it into a number, which is an age or any kind of relative date. And that's what we're going to do for further analysis. So that was a trick that I wanted to show you. And that is how come in the actual data set, I have the customer's age and not the date of birth. And well, let's talk about why we're going to do that. I think on the next slide, now that we have the data. Now, I said we've got these different kinds of data in demographics. You can have numeric data sometimes, although in my data set, I didn't have any numeric demographics. Now, if you have numeric data and you want to analyze churn rates, you can use cohorts just like I showed earlier for metrics. And we'll do this in just a second with listing 5.1, which I mentioned to you earlier. Now, if you have a date demographic data, how can you analyze churn with cohorts? Easily, you just convert it to numeric by referencing a base date. In this case, I converted the date of birth to an age by referencing the observation date. So the time from the date of birth to the observation date is the customer's age. So now we want to know how churn depends on the customer's age. And we'll do that with cohorts. And that's listing 5.1. So let's take a look at, get a configuration going for listing 5.1. I think it said version 17 or something like that. I might have one of these already. Here, I already have run cohorts 5.1. And my slide said, yeah, version 17, which should be the customer's age. All right, let's get listing 5.1 open. Make sure we got a breakpoint. All right, let's take a look. Yeah, sure, Danny Spark. You want to do non-data science questions? How recommended is it to use PyCharm in a company? I've read some reviews that they steal some info. Wow, I haven't read that. And I hope they're not stealing my info. This song is kind of freaking me out. Maybe we should go to the next one. Okay, it's getting a little better. But yeah, I don't know about PyCharm stealing info. I sure hope they're not stealing info, because I use PyCharm at my current company. I mean, pretty much every product is stealing info about you nowadays. I mean, look at what we do with churn analysis. Well, there's a difference between stealing info and tracking what users do. If you look at what we're doing in this churn analysis, with the churn data set, we track what the users do, and for any product or service, you're going to track what they do to figure out what the users like, right? So, I don't know, it depends. If PyCharm is tracking what I do in PyCharm in order to make PyCharm better and make me not churn, then I'm kind of okay with that. But if they're tracking what I do otherwise, that's uncool. I mean, that's generally my attitude towards tracking. So in the great Apple-Facebook debate on tracking, I'm in the Apple camp, and I don't think an app like Facebook should track what you're doing in other apps, right? Like, they want to track what I'm doing in Facebook, that's great. I'm in Facebook, they track me. But when an app is tracking what I'm doing in other apps, I consider that an invasion of privacy. So I'm on Apple's side of this debate, and I hope that PyCharm is also behaving responsibly and only collecting data about what their customers do within PyCharm. I don't know, Danny Spark. Is that at all related? I mean, I need more info. Give me a link or something so we can follow up on this report of PyCharm data stealing. Anyway, here I am running the listing for the cohort plot. That is a software engineering question, or a software question. Boy, yeah, I don't know about pretzel rocks, man. I gotta get these, trying to make the chat a little bit bigger, but I don't like pretzel rocks kind of dominating my chat like this. I guess that's okay on a busier chat, but because my chat, we don't have too many people here, let's be honest. I don't want my conversation hidden by the playlist. All right, I'll have to deal with that another time. This was my experiment in pretzel rocks. I might go back to Spotify. Anyway, if we want to do a cohort plot, this is how we do it. We've got a path to our data set. Now, in this case, it had better be data set 3. It is, as you can see here in the debugging information. And the metric to plot for the cohort plot is the customer age. So I'm running the right code here. We wanted to look at how customer age, which is a demographic, relates to churn. So first thing we do is we load that data set. And this is the data set we were just looking at. I can prove it to you, hopefully. So this is a data frame with 25,000 approximately rows and 20 columns. You can view it and you can see this is just the data set we were just looking at a few minutes ago. So I've loaded it. Next, I use a function called qcut in pandas, which stands for quantile discretization, and that groups the customers based on the value of the selected metric, which in this case was the customer age. So the result of this is a series, the groups, which indicates for each row which group that row is in. So now to get the data needed to analyze the cohorts, I use the group by function. First, I group by the metric to plot and look at the mean, and that gives me the average value of each metric in each cohort. Then I look at the churn rates in each cohort by using the group by function again, this time on the isChurn column. Having done that, I have all the data I need to make the cohort plot. And I wrap it up in a data frame for convenience. Now I'm making the plot. And here's the plot that just appeared in my other screen. And there's what my cohort looks like. Very interesting. I'm just going to let it run out now. It closes the plot when it's done, but it should be in my output folder. All right. Here it is. So this is the impact of customer age on churn for this data set. Now, would you say customer age is related to churn or not? I would say it is, but weakly related to churn. You can see that the youngest cohorts do tend to have a lower churn rate, but it's just by a little bit. And the older cohorts up above age 60 tend to have a somewhat higher churn rate. And in between, there's like a bunch of noise, meaning it kind of like behaves a little bit randomly. But I think that's the result of this being a weak relationship to churn. So Danny Spark, you wanted to use it, but IT doesn't let you install it. Well, you could probably use VS. I mean, that's probably what they'll let you use, because that's a Microsoft product, depending on, if your company is like a Microsoft shop. And I have heard good reviews of VS, I have to say, from other data scientists who use it. However, as for myself, I'm trying to, stick with the free versions that come from independent companies. We're stuck with enough products from companies like Microsoft. I don't want to use one more Microsoft product when there's a great product available for free from an independent company, which is IntelliJ, right? They're the makers of PyCharm. I'm like, hello, who the hell makes PyCharm? Boy, I am not a good PyCharm commercial. Who makes it again? Blah, blah, blah. JetBrains. I think IntelliJ is another JetBrains product. That's what it is. Yeah. IntelliJ is another JetBrains product. But anyway, well, we don't need this code open. So anyway, that was the PyCharm question. And this was the cohort for the customer age. And again, this looks like a weak relationship to churn. Not as strong, if you recall. Previously, we were looking at these behavioral relationships with churn, like this one, which showed a more consistent trend over a larger range of behaviors. But so, customer age related to churn, but more weakly. So where were we? We were talking about doing cohorts to analyze churn with demographic data. So if your demographic data is a number, cohorts work exactly like for numeric data. Well, for metrics, for behavioral metrics. I think that sentence was like a tautology, but anyway. And if your demographic data is a date, you convert it to a numeric data so that you can use the same code. So that's how we do churn cohorts on numeric and date demographic fields. And that was listing 5.1. Version 17 is the one that's set up to do the date field. Now let's talk about a new subject. Making these kind of churn comparisons for categorical data. Now categorical data means basically that the data comes in a string, or it could be a boolean true-false field. Now, categorical data has this property that's I wrote here as MECE. And that stands for mutually exclusive, collectively exhaustive, which means that you have a category gets assigned to each customer. Each customer can only have one value for the category. And if you take all the different values for the category, they are mutually exclusive in the sense that a customer can only have one, and they're collectively exhaustive in the sense that together they explain all the possible states that the customer could be in. So it's all the possible values. Now, analyzing churn in categories is more challenging than analyzing churn from numeric cohorts. Now, why is it hard to analyze churn from categories? There's no natural ordering of categories to reveal trends. Now remember, when we looked at the metric, there was a natural order to the cohorts. The bottom cohort was those with the lowest value of the metric. The next cohort was the next decile, typically. And then the top cohort would be like the top decile. So the cohorts are ordered and you can see a trend in the churn rates very often. But for categories, there's no order. So you can't see a trend in the churn rates in terms of the order. There's also no guarantee that all cohorts have the same number of customers. Now, when you use that pandas function I mentioned, qcut, it's going to try to divide the customers into equal categories. It might always not be exactly equal, depending on the distribution of your data. But typically, the groups are more or less equal in size. So it makes it easier to analyze, for reasons you'll see in a few minutes. Well, you should actually know that if you have a small number of customers in a cohort, I'll just explain, it can be hard to get an accurate measure of the churn rate. So the more customers you have, the more accurate a measurement of the churn rates in each cohort you'll end up with. So that's why having small cohorts or cohorts with few customers can make it difficult to analyze. Lastly, with categories, you don't have a prior expectation about how the category should be related to churn. Well, usually you don't. At least for metrics that measure customer behavior, you have a prior assumption that the more they use the product, the better. So the more they do behaviors, which are product use, the better it will be for retaining the customer. But with categories, you don't have a natural prior to kind of compare your results to. So that's another reason why it can be harder to analyze categories. Hey, no games for old men. Are we doing imbalanced data? Yes, we are doing imbalanced data. We're talking about categorical analysis of churn, and churn is generally imbalanced. I think on a previous slide I showed that the churn rate is around 5%. So about 5% of the customers churn. Well, and we'll see that in just a minute. So this is very unbalanced data, no games for old men. And I like your username. That's pretty cool. And I like the movie No Country for Old Men. All right, so solution to all these problems analyzing the unbalanced churn rate with the categorical data is to use a more rigorous approach to our cohort comparison than we were using for the metrics. And this is called using confidence bounds. So for those of you who already know about confidence bounds, you're about to hear about it again. Those of you who don't know about it, this is what confidence bounds are all about. This is my picture. It's all about the sample churn versus the population churn. I'm going to try to explain briefly an important statistical concept. Now, on the left is an illustration of the universe of all possible customers. Now, just bear with me for a minute here. We would like to know the churn rate for all possible customers, right? Like, let's say we want to know the churn rate among customers from, one country. Well, we'd like it if we could measure the churn rate on everyone in the country, but you can't. That's why I say here, I put this like X through here. You can't possibly measure the true churn rate on all customers of a given type. Why? Because you only have the customers that you got. That's shown here. Your customers. So you can measure the churn rate on your customers, say from a given country, and that's your observed churn rate. But you're never really measuring the true churn rate on all customers from that sample universe. And I don't know if that makes sense to non-statistician people. To statistician people, they're like, oh, we already know this, and your explanation's not that good. I'm trying to make an explanation to non-statisticians. So you've got the true churn rate in the universe that you'd like to know, but you're only observing one given churn rate, which is the churn rate from your own customers. That's the problem. So we use statistics to come up with best and worst case estimates of the true universe churn rate. So remember, we want this true universe churn rate. We don't really know it. Wow, I'm getting spammed on my chat. I hate that. I don't want to become famous or buy followers. Thank you very much. I'm happy here with a few followers, not famous, but I get to talk about what I want to talk about and listen to what I want to listen to. Anyway, so we were saying you come up with from your customers, and the amount of customers you have and the churn rate you observe, we use statistics to estimate the best and worst case values for the true churn rate, which you can't observe. So you can't know the true churn rate, but we can use statistics to come up with a best and worst case value for the true churn rate. And these best and worst case values are called confidence bounds. You can also call it a confidence interval, because it's the interval in which you think you're going to find the true value. So the high confidence interval is the range between your worst case churn rate and the observed churn rate. So remember, you've still got your observed churn rate. That's the churn rate on your customers. And then your low confidence interval is the interval below your observed churn rate to the best, the lowest possible churn. So you use confidence bounds to kind of widen the view of where you think you might find the churn rate in a given cohort. And then by comparing confidence bounds, we make the comparison between cohorts more rigorous. So hopefully that's a reasonable explanation of confidence bounds. Anyone on the chat? Do you know confidence bounds? Don't know confidence bounds? You want to tell me how my explanation of confidence bounds was? That was my no math explanation of confidence bounds. So we're going to use confidence bounds now in our cohort analysis. So let's go to category churn cohorts, listing 10.2 from the book. Nice upbeat song here. We got, let's see, Brazil by Approaching Nirvana again. These Approaching Nirvana peeps are all over the copyright-free music. Now I need to edit my project settings a little bit because you can see here, chapter 10 is not highlighted blue, which means, yeah, same as confidence intervals, Danny Spark. I mean, people call them somewhat different things. I am going to go to my Python settings and I need to tell it that chapter 10 includes code. See, it's not highlighted here, which means I have to click sources. And now chapter 10 appears in my sources. And we will calculate confidence intervals, confidence bounds, whatever you want to call it, in this listing. All right, so it's chapter 10, listing 2. So it's similar to what we were doing with behavioral metrics, but we're going to do it with categories. Let's see. None of these look so good. Let's just like duplicate this and say run, and let's call it category cohorts. This was supposed to be chapter 10, listing 2. Looks good. Let's debug it. So I hope you're all enjoying the music and not too put off by Pretzel Rocks taking over the chat. I'm going to have to think about what I do on that. Should I subscribe to Pretzel Rocks or should I go back to Spotify? Anyway. People from business would be more comfortable with the term confidence bounds. Yeah, confidence bounds, confidence intervals. I don't know. Well, anyway, here I am in my analysis. I think I'm going to start by loading the data set by calling this helper function. So first, I check that my file exists with an assert statement. Looks good. Next, I load the data set into a pandas data frame, as usual, setting the index to the first 2 columns. Now, the next thing I'm going to do is actually fill missing values in the column. And this is something we didn't talk about, which is what do you do if you don't have all your categories? In this case, let's see, which category am I working on? I'm working on the channel. I do that with the fill_NA function. And what I'm doing here is filling NAs with string NAs, so that if there were any missing values in my data, they will now have the string -NA-. So that'll work out for the analysis. So I have filled the missing values with NAs, and that's it for preparing the data. Next, I'm going to call another helper function, the category churn summary. And this is where I'm actually going to do the analysis. Okay. First, I'm going to use that group by function. Remember group by, we saw that earlier. When do I recommend to fill missing values with the mode? Okay. Well, personally, for categories, I almost always like to fill with just a string that says missing or other or unknown. Because, yeah, I would only want to fill with the mode, meaning the most common value, if I had good reason to think that the missing values took on the most common value. Because missing values can actually tell you something, particularly if it's a field that the customer had an option to not fill in, and they don't fill it in. It shows you have a lazy customer, for example, or a customer who's just clicking through and doesn't want to fill in stuff, or a customer who doesn't want to tell you what country they're in, or whatever that piece of information is. So because the missing state can actually be informative, it's usually better to just fill it in a way that you keep the knowledge that it's missing. You could come up with counterexamples, but usually, yeah, I like to do it this way. So, now we're going to do some sums and means to count how many there are of each category and what the mean churn rate is. So this is a more complicated use of group by. Okay, No Games for Old Men says, just do a probabilistic simulated data for null values. LOL. But yeah, he's right. Better right than fancy. Yeah, there are fancy things you can do to fill missing values. That's another key question is, how important is it that you fill the missing values? Because you can make a complicated model to fill the missing values with the most likely value. But you got to really want it to do that. Especially because a lot of good predictive algorithms nowadays, like XGBoost, do just fine with missing values. Like I said, the missing value can even be predictive in some sense. Anyway, so we're doing a more complicated example of the group by function. So I group by the category column, and for my you can specify an aggregation for the group by in a dictionary. So I'm aggregating my category column with the count, and then the isChurn column with sum and mean. Let's take a look at this summary result here. I actually haven't looked at this for a while. So here is my summary result. Let's view it as a data frame. So I got all this from that one row. I got for the channel, I got the counts. So I had 13605 App Store 1, 3984 App Store 2, 7171 web. So this is the counts of the occurrence of each category. This is the counts of the churns. And then lastly, in this column, I have the churn rate, which is the mean churn rate. So now I can actually already see, it looks like the web channel has the highest churn rate. App Store 1 has the lowest, and well, in the middle, I should say, and App Store 2 has the lowest churn rate. So there does look to be differences in the churn rates. So we've already got that out. And that was just from using pandas group by with the ag function on the groups. Now, next I'm actually going to do the confidence bounds. So this is what I was talking about in the last slide. Confidence bounds, confidence intervals, error bars, it's all the same thing. I'm going to use a statistical function called proportion conf int. And that is from stats models, package, stats module, proportion submodule, I guess. And I'm not going to go into the details, but this is the confidence interval function you want to use for this kind of data. Proportion, because we're looking at proportions or percentages. So it's really a confidence interval on a percentage or a fraction. And there is also here this thing called where I set the method, and that's where I'm really setting, this is the method that you want to use for unbalanced data. Back to No Games for Old Men's comment that, yeah, we're doing unbalanced data here. So you have to use a particular method to give your confidence intervals. Now, the interesting thing here is what goes into the confidence intervals. The first parameter is this sum, which is the number of churns. And the second parameter is the count, which is the total number that the category occurred. Now, the reason you're giving both the total number of the category is because the more observations, the tighter the confidence bounds or confidence intervals will be. We'll see examples of that in just a minute. And that's going back to this concept that you're observing on your customers, which is a limited number, and you're trying to estimate the true universe churn rate. But the more customers you have, the more confident you are that your customer churn rate is closer to the true universe churn rate. And that's why you'll have what they call narrower confidence bounds when you have more customers. And we'll see that in just a moment. But so this function, proportion conf int, it needs the number of total number of observations as well as the churn. So that's why we got them both out in the summary data, right? So this one function call is going to give me the confidence bounds. And now all I'm doing is adding the confidence intervals that I calculated. These are my intervals. Let's look at it. So this is my data for the confidence intervals. I have the low end for App Store 1, App Store 2, and Web, and then the high bounds, or the end of the high interval for App Store 1, App Store 2, and Web. And then we're going to plot these all in just a moment, so it all makes sense soon. Okay, let's go. So now I'm just putting them in my data frame, actually. So I'm going to put these all in a data frame. I'm putting in the low confidence, the high confidence, the size of the low interval, the size of the high interval, and then I'm going to save it all. And I just did 2 CSV. So now I just saved out this little table. And you might notice there's kind of these weird two-part column names on some of the columns. that's just what Pandas does when you made columns from these aggregates. So here I had my counts for each channel. Here I had the number of churns in each channel. This was my churn percent, which is just column C divided by column B. And then in these other channels, I actually have the content of my confidence bounds and confidence interval analysis. Well, this column is actually just informative. This shows me what percent of my customers are in each category. So this is just useful, good to look at whenever you're looking at this kind of data. So this is what it saves out. So now let's get on to the visualization, which will be the last part of this listing. So that was making my summary. And lastly, we do a category churn plot using the summary. This is, again, just another function in the same file. So it looks like I'm bouncing all over the place, but really, I'm just right here in the same file, right? Okay, so first I check the number of categories. This is going to be a plotting exercise. 3. And I'm going to make a figure. And then I'm just going to make a bar plot. And I'm giving it the y error parameter from my summary to give it the confidence bounds. So here I go. There's my visualization with the confidence bounds. And the rest of this is just plot annotation. But I always say plot annotation, very important. All right, and then it saves the plot. So now I should have that one in my output directory here. All right, so let's look at what we have learned about churn for the channels in this data set. We have learned that App Store 2 has the lowest churn rate and the web channel has the highest churn rate. Now, we also have plotted these confidence bounds or confidence intervals, whatever you like to call them. Now, how do you use the confidence bounds or confidence intervals? You use them when you want to compare two categories to see if the two categories, if the difference between them is significant or not. And the way you do it is basically just look at not only the height of the bars, but look if the confidence intervals or confidence bounds are touching each other. That's right, look if they're touching. So for example, the difference between App Store 2 and the web in their churn rates is very significant because the confidence bounds, as shown by the edges of these error bars, are not touching each other. If they were touching each other, then it's a less significant or maybe insignificant difference. Now actually, App Store 1 and App Store 2 is borderline because the confidence bounds touch just a little bit. But in this case, I would actually say that App Store 1 and App Store 2 do have a significant difference in their churn rate because, well, the bars barely touch. And in the same category, we had a significant difference with the web category. So that kind of lends evidence, to me anyway, that this category is significant. Now, there are more advanced statistical tests you can do for significance, but I'm not going to do them because usually for churn, it's not worth your time. It's good to do some good analytics like this, include your confidence bounds, and then make the comparisons on this basis. So that is comparing churn in cohorts with confidence bounds. That was listening 10-2. And here's a summary of what I was just saying about reading significant differences in confidence bounds. All right, if the confidence bars are not overlapping, it's a significant difference. If the confidence bars overlap by a lot, then the difference in churn rate is not significant. And I'll show you an example of that in just a minute. If the confidence bars are just touching or overlapping a little bit, you have to use your judgment. And like I mentioned in that case, it might help to look at other possibilities for the same category. All right, let's do another example, and we'll look at the same cohorts for the country category. This is Chapter 10, Listing 2, Version 2. I'll just go in here and just add a version 2 parameter. And we can run through the same thing again. I'll do it quick this time. First, let's make sure we have the right column, it's country. So, if we go into prepare the category data, we will fill missing values in the country with NA. Oh, by the way, we didn't see any missing values in the channel, did we? Because you don't see any category for NA. Try it again here. So we filled missing values. Now we're going to do the actual analysis. I call it the summary. This is where we're actually doing the churn rates and the confidence bars. So we do the summary, the all-important summary. This time it should have a lot more values because there are a lot more countries. I don't know if you remember from earlier, but there's something like 16 countries. So we got a lot more countries this time. A lot more categories. Next, so we did the group by to get our counts of the number and the churn rates. Then again, we use proportion confident function to actually calculate the size of the error bars. The rest of this is just putting it into the data frame. So I'll just skip out of that. And again, we'll make a plot. This time we have, 27 categories. I didn't realize there were so many. And now I made a plot which is much larger. Doesn't even fit on this screen. But still, stepping through the code will make all those error bars. And I'll just let it run out. Let's look at the category churn rates for the country variable. Now here in my output directory. Wow. So, this is a big difference from the last case in a few respects. Danny Sparks, hey Carl, is this using the predicted churn rate? Actually, nope. We are not actually doing churn rate prediction yet. This is only analytics, you would say, or churn rate analysis. So right now, we're just looking at the data set and saying, what are the churn rates in the different categories, and how significant are those differences? And actually, next stream, kind of getting ahead of it, next stream we'll do some prediction using this. But this is all just looking at the data as it is. So the thing I'm seeing, what we're seeing here, I'm going to zoom in a little bit. Here, with these churn rates in the countries, there's a lot more of them. And also you might notice, and there's my NA column. So we actually filled some missings with NA. What you're noticing, hopefully, is that there's big differences in the size of the confidence bounds, or the error bars. If we go to a country with a lot of people in our data, like US, we have a relatively small confidence bounds relative to the churn rate. So this churn rate in the US is around 5%, and the confidence bounds stretch just up above 6, kind of. But then if you look in SE, I don't even know what country that is, actually. If anyone can help me. ISO country code SE? I don't remember. Anyway, the churn rate is a little bit higher, but now look how big these confidence bars are. So now this is a case where we would say the churn rate in country SE, the observed churn rate is higher than in the US, kind of like 7% to 5%, roughly. But we would not say that that difference is statistically significant, or just significant, because the confidence bounds on SE are so large, they include the entire range of US. So even though we see a higher churn rate in SE, it's not significant statistically. It's not different in a statistically significant way compared to the US. And in fact, if you look at all of these confidence bars, they're mostly all overlapping. Let's actually look at the data a little bit. And I can illustrate a little bit more clearly what I was just saying. Here we go. Here's the table that we saved out for the countries and their counts and churn rates. So you can see there's big discrepancy in the counts for different countries. Let's see. I want to freeze panes. Make this easier to read. So these are the churn rates and the size of the confidence intervals themselves. Now, having a lot of customers is good. A lot of examples makes it easier to measure the average. So I'm going to say green is for a lot of customers, right? So China has a lot of customers. NA had a lot of customers too. And lastly, US, 3,500. Okay. Now, when you look at the size of these confidence intervals, which is shown here, basically big is bad. So I'm going to format, high, bad. And you can see that this actually lines up with the number of customers. So SE, let me zoom in even more. Category SE had only 209 customers in it. And so the confidence interval was actually, was actually 2.7% on the low side. Looks like even more on the high side. So they're not perfectly symmetric is something you're seeing. And that's because we're using that estimate for the Wilson estimate for unbalanced data with rare outcomes. So you can see the categories where we have the most observations have the smallest confidence intervals. And the categories where we have the least observations, in this case only 200, maybe 400, have these larger confidence intervals. So that illustrates how when you don't have enough observations, it can be hard to tell if there's a significant difference in the churn rates. So hopefully that is all making sense so far. So zooming out again, it actually looks like there might not be any significant differences at all between the countries. And there's a lot of categories, which is kind of annoying. So what do you do if you have data which looks like this? Because remember, it's nice and good to make my little toy example here. Where's my toy example? Look, only 3 categories. It's easy to tell which ones have significantly different churn rates. Hey, they all do. But you may, in your own data, have an example that looks like this, where it's just like, there's so many categories. What do we do? And they don't have significant differences. Well, I'll show you a technique that I use, which is a simple grouping strategy. That's going to be the next subject. What do you do if you have a lot of categories and you're not seeing significant differences? So here were the problems we saw with the country cohorts. Too many categories. Also, many categories didn't have a lot of data. You can call that thin data or just not enough observations. So little data led to wide confidence bounds. Hey Charua Katarina, welcome to Data Science Streaming. Hope you like data science, and I also hope you like electronic music. If you like those two things, then you're my new best friend. Cool. Do you like coffee too? That's like my other passion. So anyway, we're going to group together the thin categories, and I'm going to show you a simple way to do it. This is an example, and I'm showing you a simple schema. Coffee and matecito. Sounds good. So this is showing a way to group these categories. So I had countries, remember, and the countries were from all over the world. So I'm going to propose to group my countries into regions of the world. And this is what I'm showing in this dictionary. This is like a Python dictionary, or you can imagine it as a JSON, JSON data in the same format. So this shows that for APAC, which stands for Asia Pacific, I'm going to map these countries. Australia, I think this is Indonesia, India, Japan, Korea, New Zealand. Then for these countries, I'm going to group them all into my Europe category. So what I'm doing here is I'm planning new categories that I'm going to make from my old categories. We're going to see how to do this in just a sec. And then for Latin America, I had Argentina, Brazil, Colombia, Mexico. And for my North American group, I had US and Canada. So now, why did I come up with those categories? In this case, it's just based on my own knowledge of what regions people live in. And I used a little editorial judgment in putting Mexico with Latin America based on linguistic similarity rather than with North America based on geographic similarity. But what I'm really using here is my prior knowledge of what regions all these countries exist in. So let's go to listing 10.3, which is going to do grouped category churn rates in cohorts. But so basically like the last listing, but now I'm grouping them together. Back to the code, which is where we should be. Now you can see in this listing, I'm reusing my helper functions from the last one. Remember, I had the category churn summary, category churn plot, prepare category data. If you were on the stream like 15 minutes ago, you saw all that. Now I got to change this to make a new configuration. How about? Let's call this grouped categories. And now it's chapter 10, listing 3. All right, let's hit it. Okay, the first thing I'm going to do is prepare the category data, which we did just 10 minutes ago. So I'm just going to skip over this one. Now I have my churn data. And remember, the main thing I did in this function was I loaded it and I filled missing values with NAs. Well, with a string that says NA, rather. Now I'm going to go into my function, which is actually going to do the grouping. Now my grouping, I should mention, remember I showed you that, is in this dictionary. So I passed that in. That dictionary we were just looking at on the slide, I passed it in as a parameter here. And I'm still working on the country column. So now I go into this helper function. Now the first thing I'm actually going to do is I'm going to invert my dictionary. Donde sos churara? No, sorry, only speak English. I wish I spoke more languages other than programming languages, but I'm only fluent in multiple programming languages and not spoken languages. I apologize for this. Anyway, we are going to invert the dictionary, because remember, the group dictionary, just checking out where Charua is from. I'm curious where you all are from. How about you, Larix CS? I always like to know where people are from around the world. I thought it was Spanish. I'm not that dumb, by the way. I mean, I am dumb, but not that dumb. Anyway, so the thing is, I want to map my countries to my regions, but actually, if you look at my dictionary, you might have noticed this is a map from regions to countries, which I did because it's simpler. It's more compact to write a mapping of region to country. But now I'm actually going to invert the dictionary with this Python one-liner. Oh, cool, Argentina? Nice. I had a coworker in Argentina at my last company. Now, this one-liner uses list comprehension in a dictionary to invert the dictionary. So I'm I started out with my grouping dictionary, and for key in groupdict.keys, that's going to go like APAC, North America, Latin America. And for value in the values that you look up from that key, which we know is a list, remember, I'm going to map from value to key. So after this one-liner, now I have my group lookup variable, which maps from country to the region that I wanted to go to. So this is a very cool Python one-liner to invert a shallow dictionary like that. I don't know, I think stuff like that is cool. I hope you liked it. Now I have what I need to map all the countries to their regions. I make a new column name for it. And now to actually do the mapping, I'm going to use the apply function in the data frame, which is another cool Pandas data frame trick if you haven't seen this before. So I'm going to set the value of my new column to be this application. And do you guys know lambda functions? It's basically defining a small temporary function. So apply needs a function. You pass a function to the apply, and the apply will be used on each row. So my function is to look up in my dictionary x, if x is in it. Otherwise, just leave it the same. And doing these quick few lines achieves my remapping of regions to country. Let's see. And now it says I'm actually going to drop the original category column. Okay, that's reasonable, I guess, in this kind of analysis. So now, let's see. Let's look at my churn data now. Now I lost my country column, but if I go over to the end, I have my new country group column. And that's what I just accomplished with that code. Now I'm going to use my churn summary function again. I'll go through it real quick because we've only seen it once or twice today. I use the group by function and aggregation to count the number of values and churns for each category. And then I use stats models, stats proportion, those are the package and module, and the function proportion confident to get my error bars. Using the Wilson method, because churn is rare, my data is imbalanced. Anyway, that really does the analysis. The rest is actually just writing it into a data frame to save it. And lastly, I'll do the churn plot. Given the data in that group data frame, it's pretty easy to actually make the churn plot. Now I only have 6 categories instead of 27. And I make a new plot. Starting to draw my categories, there they are. The rest of this is just annotation. All right, let's look at what it saved. It's going to print out. It always prints out, oh, I saved it. Let's see. Nope, wrong thing. We want to look here, find our new plot. So here's the new one we just created. All right, now how do the churn rates compare between my regions? Are there any significant differences? The answer here is no. Remember that to have statistically significant differences between the categories, we should see that these confidence bars don't overlap with each other. But in every case, in every comparison, the confidence bars overlap. So these are not statistically significant differences. A few other things worth noting. You may notice that I didn't include China, the country, from my data in any group. Why did I do that? Well, that was, again, an editorial judgment call I made because China is kind of a separate market. In fact, this is unrealistic because there's no such thing as a social network that you can use in China and elsewhere in the world. But again, this is just a simulated, made-up data set. But I said pretend there was such a social network. Then it would be reasonable to consider China as its own category because it's so big, has so many people, and it's culturally and politically distinct from the other countries that I grouped in the APAC region. Like I said, there are also editorial decisions you can make in grouping your categories together. Let's talk about it. This was the code. So how to group categories. Now remember, there's actually different situations. Consider first the case where there's not enough data in some categories. And that's actually what we really had. So this was the situation here. We had a lot of categories, and some of them had so little data that the confidence bounds were huge. So there's not enough data in your categories to really understand or analyze. What do you do? If you don't have a lot of data, you group by known relationships. Just like I did. Well, I know countries are in regions, so I'm going to group my countries into regions. For example, let's make a few examples. Sorry for clearing my throat on the mic. That's me clearing my throat on mute. Ah, you're Brazilian. Cool, Chura Catarina. You're Uruguayan and German descent. Oh, that's not a real mess. It's good to be a mess. I'm a mix of personally, a few different kinds of Europeans. And my kids are biracial, so I'm all for the mixes. Anyway, let's say you have categories which are operating systems, and you have too many categories, right? You could group by major releases. I'm just citing here examples that you might come across where you can use your knowledge of the situation to come up with a category grouping. Also, I was going to add, I have a coworker in Brazil. My new company is very global, and we are hiring a data science team with members in Brazil, data science and machine learning engineering, because we're launching our product in Brazil later this year. So that's for Charua Catarina. Yeah, we got peeps in Brazil at my company, and hang in there. I hear it's been pretty rough down there lately. Anyway, consider industry sectors. If you have a lot of industry sectors, you might group related ones. Like you could group together banking and finance in one group, and then like consumer and retail in another group. Or consider categories for occupations. You could group together related fields like doctor and dentist versus software engineer and data scientist. So all I'm just saying here is making examples of how you can use your prior knowledge to group categories. Blah, blah, blah. I say here, don't overthink it, but do talk to experts who really know about this data. Because you can spend a lot of time agonizing over how to group these things together, but you don't have a lot of data and you're just trying to do your best in this scenario. So don't agonize, but do talk to people who know the data. Evaluate how well your grouping solves the problems. You want to even out the size of your categories and get narrower confidence bounds, which in our example, where's the other example, it worked. We now have 6 categories. I actually never showed you the data. Let's see. This was the result of our grouping of the countries. You can see here now in the new result that every category has, from 3,000 to 5,000 individuals in it. And this is actually the percents in each category in this column. So the smallest category still has 11% of the data, and the largest category has around 20% of the data. So we did a good job of evening out the data into different groups, and that's one of the things you want to go for. All right, now, what if you actually have a lot of data in all your categories, but you've just got too many categories and it's a pain in the butt? It's hard to interpret. Well, in this case, you can actually use your data to also do a better grouping. So you can calculate the churn rates in all your groups, and assuming you have a lot of data in all your categories, they will all have narrow confidence bounds to begin with. Oh, I'm glad you like the categorical treatment theme. Yeah, these are just some, honestly, this is not a very advanced approach. This is just more analytics than data, than like statistics or machine learning, really. But anyway, if you have good churn rate estimates, then you can also use them in your grouping. So you group together when two conditions are met. First, the groups are logically in one category. And second, if they have a similar churn rate. So you use the churn rate as an additional piece of information when you're deciding to group or not. But you don't group on the basis of the churn rate alone. You want to combine your prior knowledge to the churn rate once you have enough data to make sure the churn rates are significant. So, I hope those guidelines are helpful. You could definitely find yourself in either one of those scenarios where grouping will be useful. The advice on the last slide still applies. Don't agonize over this, but do talk to someone who knows your data and your markets well. It'll be helpful. So, what about, well, there's one last subject. I think I'm actually basically done with what I was going to do for today, because that shows how to analyze, do simple analytics on categories, how to get the data, and analyze it with confidence bounds. What about confidence bounds on metric cohorts? Why not use confidence bounds in metric cohort analysis? Well, there's not a strong reason not to, actually. I never do it because it makes the plots look kind of cluttered, and it's usually not necessary to understand the significance of the metric cohort plot, because remember, metric cohort analysis has advantages over category cohort analysis. Those are that the data has a natural order to help you interpret it. You're going to have approximately equal numbers of customers in each cohort, and you have a prior expectation of what the relationships should look like. Now, that's why I don't do it. But if people want, I was going to try to do a little live hacking. Let's add confidence bounds to the metric cohort plot. And I haven't looked at this code for a while. So this is going to be a real live hack where I don't really know what I'm doing. I did this once before and it shouldn't be too hard, but let's see if I can remember how to do this. Uh-oh, Churua Katerina, you're struggling with confidence bounds. What is the struggle? Please let us know what the struggle is and maybe we can help. I kind of explained the concepts earlier in the stream. You might have missed the conceptual explanation. But what I'm going to do, I'm going to go back to the basic metric cohort plot and see if I can figure out how to add confidence bounds on it. So first thing I'll do is I'm just going to save this as a new listing. With save as. Whoops. It's going to be listing 55. I'm just going to give it the next consecutive number. This will be cohort conf plot. Now, let's see. I think I need to interrupt the flow around here. And then bring in the code from the other listing that had the confidence bounds, the calculation here. So I'm going to need to bring in these two lines. So what are you struggling with, Charua Katerina? Any question I can answer about the confidence bounds? Now, what I need to do is, instead of grouping by the category column, I'm going to group by the groups that I got from QCut. And I guess I'm going to have to I'll use the metric to plot variable now. Now, I think at this point, I should probably just see if this is going to work. Well, this is not going to work. You can see my error here, unresolved reference. Easily solved by copying it from the other file. So now this is not done, but I basically want to see if this is working. Oh, cool. You're collecting data from forests in northern Brazil, but the areas are extremely huge and the variables are heterogeneous. Oh, so you don't have enough data to get significance. That's what you mean by struggling with confidence bounds. You have a real use case where you don't have statistical significance. Oh, no more money to do the research? Well, maybe you could use the approach that I was just showing of, grouping data from different regions. Like, you could group together neighboring regions, maybe. It's just a thought. I mean, I don't know if it would work with your data. It always depends. So to run this listing now in the Fighting Churn with Data software code framework, I need to make a new configuration for the listing, which goes in these JSON files. And because I'm adding a listing in Chapter 5, based on the Chapter 5 metric cohort listing, I have to put it in here. So I'll make a new entry. This is showing you how to hack the configuration and code in Fighting Churn with Data if you ever want to. This is going to be listing 5. The name will be, well, what did we just say it was? It has to match the file I just created. You think it could work? Yeah, it always depends. Yeah. Depends on exactly how much data you have in each region, each category really. But small data, I think, is the hardest. Many people think that big data is hard. No, no, no. Those people have never really worked with data. Big data is a problem solved by software and engineering. So if you have big data, it means you have to use appropriate hardware and infrastructure. No problem then. But if you have small data, not enough data to get significant conclusions or form a large enough data set, there's no technological solution for small data. Only clever data science can sometimes help. Anyway, so this new listing has to be, cohort conf plot. Is what I called it. And let's see, I'm going to need, I need some parameters. Let's see. I guess, oh yeah, I need a metric to plot parameter. Whoa, too many versions of listing 5.1. That's like the most used listing in the book. So let's see. Oh, and I need a name. Oh no, I had that. I need a name, I need parameters. I think this should actually work. Think it'll work? Let's try it. Need a new configuration to call this one. I'm going to call this confidence metric cohorts. This will be chapter 5, listing 5, if it works. Okay, let's see if I even get into my function now. And then I can try debugging the summary and the intervals. All right, so I'm here. I've loaded my data. I think this is the smaller data set. Let's see. Yeah, I've only got 10 columns in this one because this is my data set version 1. Apparently 31,000 rows in this version. So this is my original grouping where I showed this earlier that I'm going to group by the numeric values using Panda's QCut, which stands for quantized discretization. So then I'm going to calculate the means and the churn rates in each cohort. Now this is the new step where I'm going to try to get these counts. Let's see if this works. Ah, I think it worked. Let's look at the summary. Yeah, it looks like it's working. I've got on each interval, it uses the names or the endpoints of the interval as the row names. I have the counts and the mean churn rates. All right, now the next key step is if I can calculate the intervals from them. This also looks okay. All right, so there are my intervals now. The high end and the low end of the interval. All right, so now the first part of this is working. Let's see. I'm going to stop now and go back to working on the code since I have this like basically working. Let's see, the easiest thing I can do is just put this into let's see. Let's see, I need to get these into this dictionary and I'll save them out. Let's see. I'll look at the syntax I used here when I did this. It's just intervals 0, intervals 1, okay? Just reusing my code from listing 10.2 here. And I guess I can put these ones in too, right? Looks like I'm using pretty much the same syntax. Except now I'm using the name plot frame for my data frame. You know, now I actually just want to run this out and see if it works. And this should work as far as saving should work as far as saving the results in the data frame. And then I'll see if I can figure out how to plot it. I'm just going to run it through. Oh, it's crashing. Oh, I see. I didn't replace summary everywhere that I need to. Let's try it now. Still getting an error. What did I do? Ah, the name for the churn column is now churn rate. Slight modification because I'm getting my churn rate from my previous column. Yeah, I don't need these parentheses for the tuples. We were thinking about using the data set to create models and generate new data to feed a new data set. Okay. So could be possible to check if it would fit in the confidence bounds. But this kind of change depends on government approval. Sounds weird, and it is. Yeah, well, I guess there can be political implications for the government. I mean, I never worked in government, said. But maybe you could try it and see if the results look promising, and then get permission if it looks like it would work. I don't know. It's a hard problem dealing with small data. There's like no good solution. That's crazy if you have like politicians telling you what you can do with your data too. I have not been in that situation, but I'm sure it's the case for many data scientists. Hey, well, I got the data to save. All right, let's see. Oh, actually, maybe it's not saving that result in the data frame. Oh yeah, I just plot it here. All right. So I don't need all these, but what I need to do is figure out, I could save the data. How about that? I just want to see the result. Save path equals churn cohort.csv. And now we'll just do frame dot to CSV, save path. I think that's all we really need. Let's see. Was I using any? Yeah, I was just using to CSV and the other one too. All right, let's try it again. Because again, I want to look at these results. Quote, sorry, this is Brazil. Well, you're welcome, Charua, Katerina. Hopefully this is encouraging or at least not stupid advice. Let's see. So now I have that data that I just made in a CSV, which is good. I just wanted to eyeball this. And at least I've now accomplished this. So now I have confidence bounds. I have the confidence intervals on my churn rates for this plot. So I could do this. And I have the low interval. I mean, these are all the percents here. So a lot of these confidence intervals are pretty small. Only around 1% on the size of the interval is 1%. Now I have to figure out, the last thing I need to do to plot this is I need to figure out how the plot function can take error bars. And for this, I actually don't know the answer. So I think I'm going to have to Google it. Let's go to the internet and try to solve this question. Unless someone on the chat knows. How do you add error bars on the matplotlib pyplot plot function. So, like any good programmer or data scientist, if there's something I don't know, I'm going to go to Stack Overflow or whoever can answer it for me. Here we go. I'm Googling. Here, I'll show you what I'm Googling so we can all get in on the Google fun. Matplotlib plot add error bars. Maybe I should just use the error bar function. That might be reasonable. Let's see. In the error bar function, I use x, y, and I have the y error and the x error. All right, let's try this one. I don't know if anyone's used this before, if you have any advice for me. But here I'm passing in the data. Can I use this signature where I pass in the names of the metrics and the data in a data frame? Let's look at the error bar function. Well, it does allow you to use data. I think this actually might work if I just add the y error and x error. Let's see what it wants for y error and x error. Float or array like. Optional. All right, this might not work in the current form. Maybe what I should do is I should actually do this properly. So the y value is going to be plot frame churn rate. The x value will be good music for coding. I'm satisfied with the music on Pretzel Rocks. Although, like I mentioned earlier, I'm not so happy with Pretzel Rocks taking over my chat. I'm going to have to see what I can do about that. They might get me to subscribe. All right, so let's look at this function again. It should be x first, then y error, then x error. So, x first, then y. And now we need y error, you know why I'm not seeing, I was wondering why I'm not seeing the right parameters pop up, but I never changed this to error bar. There we go. So now when I start typing x error, yeah, it should pop up. And let's see. What are these supposed to look like? Error bar sizes. So for me, that's going to be these fields. Low int and high int are going to be my error bar sizes, if I've done this all correctly. So this should be low int. Man, if I did this all right, this actually might be all I really need. So let's see. I actually don't know about these other parameters, if they're going to be acceptable to this function, because I changed my plotting function here, but I don't know. Like a good hacker, let's give it a shot. Let's see. So as usual, I'm loading my file, loading my data. I do my normal grouping for the metric cohorts, calculate the mean of the metric in each cohort and the churn rate in each cohort. Now I'm actually doing the summary that I need to calculate the confidence intervals and using the confidence interval function. Okay, now comes the moment of truth. Does my plot error bar function call work? And what does it do? Oh, hey, it worked. I think this looks good. Just going to let the rest of the function run and let's take a look. Hey, I think this really worked. What? Hey, where's my saved file? Oh, there it is. All right. Yeah, this is good, man. This is good. Or people, women, anyone, peeps. All right, so now we have error bars on the cohorts. So this was a metric-based cohort analysis. So remember, the way you read this is each point represents a cohort. This cohort is like the bottom decile. And these are all in terms of this metric, post per month. So the bottom cohort has practically 0 posts on average. And the top cohort has more than 175, close to 200. The y-axis shows the churn rate. And so you can see that as you increase in the cohorts, the churn rate goes down until you get to around 25 posts per month. And then there's not as much difference in the churn rate after that. What I've done new here is I've added the confidence intervals that we calculated. And you can see that around each one of these points, there is a confidence interval. And some of these differences are statistically significant, actually. Like the difference between the first cohort and the second cohort is statistically significant. Although when you get to some of these later ones, obviously these are not significant differences. So I wonder if there's a more interesting example we can do. I think we want to do some more metrics. So basically, this live hack worked, and this is what we were trying to do. And I would say that in this case, having the confidence intervals doesn't really help the cohort analysis. I mean, in this case, it's clear that it's a significant difference, and it was pretty clear before we did it. And after we've done this, it's, less significant. Hey, I know something fun. Let's look at the customer age. Yeah, we'll look at customer age. That one, as you may recall from earlier in the stream, let's see, where is the customer? We did it earlier in the stream today. This is the customer age analysis. So here we're showing a much weaker relationship to churn, right? So now to do a different metric with our new listing, I also need to configure it. By making a v1 for the first version in the configuration. I'm going to need a new dataset path because I said I wanted to use customer age. Customer age, as you may recall, is in SocialNet 2 dataset 3, which we just created earlier in the stream. Metric to plot should now be customer age. I'm spelling it right. I think that should do it. I'm going to have to go in here and add the version 1 keyword. And I don't know, I'm feeling lucky. Let's just try running it. What's it saying here? Well, it says it worked. Here's our, and I overwrote the old file. So now here's our new cohorts on customer age. Now, are these differences statistically significant from cohort to cohort? Well, if you were listening earlier, the answer is actually no, because the error bars from one cohort to the next are generally overlapping. It actually looks pretty bad. If you go from the bottom cohort Well, if you go from the bottom cohort to the top cohort here, you'll see these error bars are just touching. So you could kind of say there's a statistically significant difference there. But the truth is, using these confidence bounds is not really the right way to analyze this kind of case for statistical significance. Really, we should be doing a regression and looking, at the regression results. And in this case, actually, customer age is a statistically significant predictor of churn for this case. Which you can kind of tell because at least like from the bottom cohort to the top cohort, there's a statistically significant difference because they don't always look as good as this one. Like this last example we did was one where we had really significant differences and really tight error bounds. Let's try one more example that we looked at earlier. We'll do a V2. And we'll just look at ad view per month. Hopefully it'll be kind of an in-between example in terms of the significance. All right. So here is what we see for ad views per month when we include confidence bounds. So here you've definitely got a case. Whoops. Want that other one. Come back, you. Here we've definitely got a case where overall there is a really significant impact on churn rate for this metric. But if you go cohort to cohort, see, this cohort is not significantly different from this one because they're overlapping. These ones are not really different. And if you go down the chart, you don't see statistically significant differences from one category to the next, or one cohort to the next. These are not categories now. But really that's okay, because over the entire range of values, you do see a statistically significant difference. So, like I said earlier, this is why I don't usually bother with the confidence intervals on the metric cohorts. Although a lot of people have asked me that. Hey, why don't you use confidence intervals on the metric cohort? Actually, okay, not a lot of people, but a couple of people have asked me that. And roughly this is why, that usually it clutters up your plot and you don't really need it. All right, so that was our live hack, adding confidence bounds to metric cohort plots. That was based off listing 5.1 from the book and also 10.2 from the book, I think. So, yeah, I think that's all I got for today. I'm going to summarize and wrap it up. So, fighting churn. What's it about? It's about targeted interventions. You could be improving your product, engaging with your customers, supporting your customers, or changing your pricing. Like, all these are good things to do that will help you reduce churn. And you can use data to do all of them better. Now, demographics and firmographics, which we were talking about today, are facts about people, and it's a demographic, or about a company, and it's a firmographic. All the examples we looked at today with the code and data were demographics, but it's exactly the same for firmographics if you happen to be working on a company data case. Now, for numeric demo and firmographics, you analyze them just like metrics. You can use a cohort analysis. Next stream, you'll see you can use them in regression, machine learning. Date demographics or firmographics, you convert them to numeric by looking at a time since a base date. And that can just be the time since the observation date for the data, like turning the birth date into the customer age, which is what we did earlier in the stream. Now, category demographics and firmographics are challenging to analyze using analytics and visualizations like we were just doing. And that's because of the reasons I listed. There's not a natural ordering, no natural prior, and you may have inadequate data in some of your categories. So confidence bounds are ranges of statistical uncertainty, or certainty, another way you can look at it, but it's the range that you think your value is in. And you use confidence bounds to find the significant category differences to make up for the problems that you have because of using categories. Now, I didn't show you the actual math behind confidence bounds. That's real statistics, which I generally don't go into. I'm an applied data science streamer, so I show you how to do it without going into all the mathematical details. I probably wouldn't be that good at explaining all the math anyway, so I'm not a professor. I'm more of a practicing data scientist. So that's the point of view that I write from. All right, well, I think that's it for today. Oh, last point. If you have lots of categories, group them. And hopefully that can help you out of some small data binds that you might get into. All right, I'm going. This was my usual live stream on Saturday today, 2 p.m. Pacific. Thank you, Charua, Katarina, and everyone who stuck with me throughout the stream. So I'll be back 2 o'clock Saturday. I don't do every Saturday nowadays. You'll see I'm skipping some Saturdays because I just have other stuff to do. And, you know, I'm not a full-time streamer. Hello, I have a day job. That's why I do this on Saturday, in case you're wondering. You can also see all of this on demand on YouTube. Every stream will find its way to a YouTube video if that's how you prefer to do your watching. Again, this is the book that this is all based on, or it's my book that I wrote, and I'm basically streaming from the book. So you don't need to buy the book. If you watch the streams and download the code, you can probably do okay. If you do want to buy the book, there is a discount code from my publisher shown here. We'll give you a 40% off discount. I think my publisher's philosophy, like many retailers, is they charge a lot but discount heavily. So just trying to help you out here. Use the discount code. This is my Twitter handle, Carl24K. Also, please follow me for updates about the code, the book, and Churn, the subscription economy. Nowadays, I also tweet about fintech because I work at a fintech company. We do embedded lending, which means lending to people using their phones. And also Charua Katarina, that's the product that we're launching in in Brazil. My company is migo.money. If you're, here I should put in http:// so it knows that this is a link, right? And we're working in Brazil and expanding around the world. So please follow me. I'll give you updates for all that good stuff. But just so you know, I tend to tweet only pretty, I don't know, kind of professional data science, industry stuff. I won't burden you with my personal life or pictures of my food if you follow me on Twitter. So please do follow me. We'll keep in touch. And let's see, next stream, we will still be doing demographics and firmographics, but we will be doing churn prediction with statistics and machine learning. Those are subjects I covered in previous streams, but this will basically show how to take the demographic data that we were looking at in this stream and use it for your statistical and machine learning algorithms. So that's kind of like the advanced level. Today was just introducing demographics and firmographics and also showing you how to do the analytics techniques, which are really valuable. But everyone likes to do statistics and machine learning, so that'll be next stream. So yeah, if no one else has any questions or comments, I'm going to call it a day. So it was a slightly above average length stream for me, but it was pretty good fun. I got screwed up in the beginning when I was in the wrong schema. I don't know if you were here at the beginning. You saw me fumbling for like 10 minutes. But I think I absolved myself by doing a good job on the live hack. So I'm going to leave happy today. So anyway, have a good weekend, the rest of your weekend, wherever you're watching from. I hope you found this interesting. Or if you watch this on demand in the future, I hope you're having a good day. And happy data science, happy streaming. I'm going to go. Bye-bye.